The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Example, rate laws of elementary steps reactions. Determine the rate law for each elementary step. Okay, wonderful. Let's take a look here at ozone first. And the rate law for ozone, I'm just going to put R standing for rate law, is just going to be that. Perfect. Now for our second one, our rate law here is just going to be concentration of ozone and oxygen here. Great. So a quick point that I want to bring to your attention here is just one here, right, for stoichiometric coefficient. That's just how we just went ahead and did it. Again, there's no stoichiometric coefficient here. We don't have one here. So we wrote the rate law here, and it's just to the first power. So even though you don't see anything here, it's like saying it's to the first power, to the first power. Wonderful. Let's keep continuing here. Now we see that we have two nitrogen dioxides, right? And then when we have two same reactant, we said that we just put it to the second power. Okay, great. Oh, forgot the rate constant there. Wonderful. Moving on. What do we have here in our reactants again? We have a bromine and an argon gas, so we can just put bromine to the second power and just place argon there. And that's it. Just as simple as that for the rate law for elementary steps. Okay, great. Now let's move forward and take a look at the rate determining step. And this is all important because we're going to do some examples and they're going to tie together in just a few moments. The rate determining step. So whenever you have a reaction that's multi-steps, the slowest step is the rate determining step in that reaction. And looking here at our definition tells us that the rate determining step is the slowest step in a reaction mechanism. Okay, wonderful. We have two different reactions here. Let me just highlight them so we don't confuse the two of them. Okay, perfect. Looking here now at our first reaction, because and these two are elementary steps. These two here, they're elementary steps. So that's what we were talking about earlier. Wonderful. So looking here at our first elementary step, right, that there is the rate determining step because it is the slower step. And the rate determining step isn't always first, as we see here. The rate determining step can also be second, as it is the second step here, right? Perfect. So now what we actually need to take a look at here is, one other thing that I want to actually show you guys here was, you see here, hydrogen iodide is being produced here and it's being consumed here actually in the second reaction. Furthermore, it's not in the product. And what did we say is being produced in the first elementary step and is being consumed in the second elementary step and is not in the product? That's the reaction intermediate, right? The reaction intermediate, a species that is formed in one elementary step and